All right, thank you. Today I'm going to be talking about an internet scale analysis of AWS Cognito. So it all started with a cloud security assessment. One of my customers asked me to review their cloud, their account, the services, and I was going through the whole list of services that they were using. In order to do that, the customer gives me read-only credentials, and I perform different enumeration tasks in order to see everything that they use. And with this customer, something different appeared, and it was Cognito. So I read in one of the tools, Cognito, and I said, what is this? I have no idea. So I went to the documentation, like any good hacker does. And if you're not going to the documentation, do it. It will improve your skills as a hacker, trust me. And this is what I found in the documentation. Identity pools enable you, the developer, to grant your users, end users of the application, access to AWS services. So end users access AWS services. End users access your infrastructure. So what could go wrong, right? Actually, a lot. So with the credentials that I had for that account, I went to the AWS console, and in the web application, you just have a section for Cognito. And in that section, I found the identity pools. And when you are the developer and you have read access to it, it will show something like this. The identity pool ID is the one in red, and as you can see, it has a format. It has the region first, or a semicolon, sorry, and the identity pool ID. That ID is randomly generated, and it's pretty long. So I got that from the AWS console, and also from the documentation, I took this function. This function is going to, and forget about the source code for a minute, is going to receive an identity pool ID, which is the ID that we saw before, and the output is AWS credentials. That's how AWS Cognito works. That's one of the features that it has. You throw an identity pool ID, and it returns credentials. All of these lines that we see here is just the implementation for that black box. It's nothing special, no hacks involved. It's just how it works. This is a function that I copy-pasted from the AWS documentation. So after I got AWS credentials for that account, I said, what can I do with these credentials? Am I going to be able to read files from S3? Am I going to be able to shut down EC2 instances? I'm not sure. So my next step was to perform permission enumeration. I took those credentials, followed some steps, I'm going to show them later, and got the permissions associated with those credentials. And this was, sorry, this was an assessment. I just got access to it and was allowed to do anything with the account. So I performed a privilege escalation attack using different techniques that involve Lambda functions. And from the credentials that I got initially from AWS Cognito, I elevated my privileges and ended up being root for that AWS account. My customer was happy. I was happy. This ended up being a critical finding for this report, for this assessment. And I started to think, is this something common? Is this something that many developers are doing, assigning a lot of privileges to AWS Cognito? Am I going to be able to exploit this in many installations worldwide? And is it even possible to perform an internet scale analysis of AWS Cognito? So all of these questions were the ones that started the research. And the next slides are going to explain how I did it. First, I'm going to introduce you to Cognito. I just kind of told you what it is, but in 30 seconds, I'm going to zoom into that. Then, I'm going to show you how I grabbed the internet in order to find identity pool IDs. Then, one of the final steps, I'm going to show you the statistics for the results of this research. And finally, we're going to try to understand why this happens. This is a tweet that I received a few days ago. I delivered this talk at Eco Party in Buenos Aires. And a few days after delivering that talk, a random guy that I don't know, he seems to be from Argentina because it says Francisco Diaz, and that's a common name in Argentina, is saying that he owned an AWS account using these techniques. And I'm showing this because it makes me happy, and also because I want to let you know that this is easy to do. There's no magic here. Once you understand, once you go through the next 30 minutes and pay attention to what I'm saying, you can go home and own your like AWS accounts, customers' AWS accounts, let's say, or the ones that are in a bug bounty. Don't hack anything random. If you do, send me a DM. Don't send me a tweet, a public tweet like this. Okay, so intro to AWS Cognito. AWS Cognito has two main components: a user directory and identity pools. The user directory or user pools is a place to store user data. So it's a database. You store the email, username, phone number, and stuff like that. It's not very interesting. And then you have identity pools. The identity pools are the component that allows users to get AWS credentials. And it works like this. In that graph, you see how the application is going to first authenticate against the user pool. It gets a token from that user pool. Then it uses the token in order to communicate with the identity pool and get AWS credentials. And finally, it uses those credentials to consume other services. Those other services can be DynamoDB, S3, IAM, any service that you know from AWS. Okay, so let me explain this with an example. We have an application. That application is called Cool Cat Pics, and it has a mobile device application and a web application. The mobile application is going to use Cognito and also the web application. So the developer wants to create a very simple experience for the users. Authenticated users can upload images of their cats to S3 directly. And authenticated users can also set a title for that image. the image that they just uploaded, it will have a title. That title is going to be stored in a DynamoDB table. The mobile application directly writes to S3 and DynamoDB. Then there's going to be an unauthenticated user. That unauthenticated user can only see the images, read the images, which are stored on S3. Are you guys following me? Make sense? Yeah? Cool. And in order to do that, the mobile application needs to use libraries. There are official libraries which are developed, at least partially, by AWS for iOS and for Android. So this application needs to embed those SDKs. And this is important for one of the steps that we're going to see later. Also, the web application that's going to be communicating with Cognito, with S3, and with DynamoDB needs to have a JavaScript library, also an SDK, in order to do that. In order to sign requests that are going to go to different services, the mobile application, the browser application that's running on the client side needs to have the SDK, the JavaScript SDK. And this is how it looks for a developer. When a developer is creating a new identity pool, he enters a name, simple. He needs to define if this identity pool is going to allow unauthenticated roles. So in the example that we saw before with the application for the cat pictures, we had two roles. The role for not authenticated and the role for authenticated. If the developer is creating that application, he needs to enable here access to unauthenticated identities. Okay? Users don't need to authenticate with a user pool before getting AWS credentials. Then, here the developer also, if necessary, can configure other sources for authenticating. So users of this mobile application could be authenticating through Facebook, Google+, and other providers. Then the developer assigns roles, IAM roles, to Cognito. IAM roles are in AWS. They're an entity, a resource in AWS, which are used to define privileges in order to access other resources. And I'm going to show that later. But in here, we are going to set two different roles. One role for the unauthenticated users in Cognito, and a different role for the authenticated access to Cognito. And this is how one of the policies that are attached to roles look like. If you want to grant a user access to list the contents of an S3 bucket, you do it like this. S3 list bucket is the action, the resource is a specific bucket, and the other action that's here is S3 star object, which is going to be something like allow the user to read and write, and finally also the resource where the user can perform those actions. So the developer, by defining this, he's going to be defining the permissions that are going to be associated with AWS Cognito. Right now, after the developer completes those very simple steps, the identity pool is created and it's ready to use. The developer is also going to get a screen like this with the identity pool. This identity pool is the one that needs to be hard-coded into the mobile application and needs to be hard-coded into the web application. Though it needs to be hard-coded because it's the entry point for Cognito. Those applications, when they need to talk with Cognito, they need the ID in order to know which Cognito instance they are talking with. And as a reminder, this is completely random. It's not possible for me to predict those IDs, and it's long, so I'm not going to be able to perform a brute force over those IDs. All right, so now we know what Cognito is. Let's try to automate the process and take this research internet scale. And the research that I did can be summarized with one for function. First, in the first line, you see for identity pool ID in get identity pool IDs from the internet. So I'm getting many identity pools from the internet, and you can imagine that any function that takes the internet as a parameter is going to be fairly complicated. So for each identity pool ID that I find, I get the pool credentials. This function is the one that I showed you before. It simply gets the credentials based on the identity pool ID. Then I enumerate the permissions, create a scoring system for those permissions, and draw some pretty graphs in order to show at conferences. And the first challenge was that identity pool IDs are random. I'm not going to be able to just do a for loop and go from the identity pool with ID 1 to the identity pool with ID 10,000, and for each of those get the credentials. That's not possible because the IDs are random. So I need to extract them from somewhere. And as I said before, mobile applications and web applications need to have those IDs hard-coded. So I can extract them from the Google Play Store, Common Crawl, and some other sources. The thing is that Google Play has 2.6 million applications. At the beginning I said, I know programming. I'm going to automate the whole process. I will download the 2.6 million applications. I'm going to decompress, decompile, grep, and this is just going to be a day of work. The thing is that Google Play doesn't like me downloading 2.6 million applications. They try to stop me after downloading like 500 applications. And I'm sure that there are many ways in which I could have bypassed those protections, using different email addresses to subscribe to the Google Play Store, using different IP addresses. I'm sure there are ways. But I didn't have the time, and I didn't want to reinvent the wheel, because I'm sure that somebody else already implemented those bypasses for downloading a lot of content. The thing is that nobody, at least nobody that I could find, made those techniques available. So I found a paid service. That service gives you a search engine capability for the Play Store. You subscribe to the service, you pay a lot of money, and you have a search just like in Google, and you type something. One of the things that you can type is SDK contains AWS. So that service is going to return all of the applications in Google Play that use the AWS SDK. That service is great, but one of the things that I said in my description was, you subscribe, you pay a lot of money, and then you search. And I didn't want to pay a lot of money. So I kind of hacked that service and got the results anyway. That's why I'm not saying the name of the service provider. From that service, I got 13,000 applications that use the AWS SDK. Those were the applications that I really wanted to analyze. And in retrospective, if I downloaded 2.6 million applications and actually only used 13,000, I would have been really disappointed. But in this case, I only downloaded from APK Mirror and APK Pure. Those are kind of alternative sites for the Google Play Store. I only downloaded those 13K from the alternative sites. It was pretty easy, so everybody was happy. Well, maybe not the guys that I hacked, but Google Play, done. I got a lot of APKs. For those APKs, I unzipped them, decompiled them, and grabbed in order to extract the identity pool IDs. Okay? From there, I got a long list of identity pool IDs. Then I wanted to extract identity pool IDs from the web, from web applications that use Cognito. So the first thing that I thought about was Google. Let's Google one of the things, one of the strings that's commonly used in applications that use Cognito. The thing is that when you search for this in any search engine, you're going to find forum posts where developers complain that this service doesn't work. You're not going to find applications that use this service. The reason is that Google is going to index the text content of a page. Google doesn't index the content of a script tag. And I wanted to search for this, which is inside a script tag. Or I wanted to search all the pages that were doing this. So it kind of became complicated. I realized that what I wanted to do was to grab the internet. I wanted to do this. I wanted to run egrep, some regular expression, and I wanted to have a huge file system somewhere with the whole internet there and get the results. Sadly, that's not possible. Or it is. Actually, something like this exists, and it is the common crawl. Common crawl is a non-profit in the US. They crawl the internet every month, and they save the HTTP results, HTTP responses, for all of the traffic of crawling the internet. They save those in a publicly accessible S3 bucket. So anyone can access the results of common crawl doing a spider of the internet. And they do a pretty decent job, around 200 terabytes of data and 2.5 billion pages. So that's content that's freely available. It's easy to think that you can grab this, but it's a little bit more complicated than that, because it's 200 terabytes. and I don't have enough disk space to store that. My internet connection is going to be really slow when I try to download 200 terabytes of data. So you need to automate it, you need to run it in the cloud. And one of the ways in which people are extracting data from the command crawl is using a tool called CC, as in command crawl, MR, map reduce job. So this is an open source tool. It works kind of. I fought with this tool for 2 days. The jobs simply hung. There was no debugging information. There was like a lot of problems with this. I'm not sure if it's not maintained. I'm not sure if I'm bad at understanding this technology. But after fighting against this for 2 days, I created my own version, and it's CC Lambda. Instead of using the Elastic Map Reduce service from AWS, I'm using Lambda functions. And this allowed me to search the command crawl. What I do with CC Lambda is have 1,000 Lambda functions running concurrently. Each Lambda function is going to download a small piece of the command crawl. It's going to decompress it and apply regular expressions to the result. Once a match is found, the matches for identity pool IDs are stored on S3. This is how CC Lambda looks like. It's pretty simple to use, and it has a small configuration file, but other than that, you just run Python, CC Lambda. This is one of the chunks of information from the command crawl. It will process each of those chunks in 200 seconds, give or take. And the matches, you have a summary there, and the whole match is stored on S3. There are around 64,000 chunks of command crawl data. For each of those, it will take around 200 seconds. And if you run the 1,000 concurrent functions, it will all take 3 hours. So you process 200 terabytes of data in 3 hours. That's pretty cool. But it's costly. One run of CC Lambda is going to consume around 300 USD in your AWS bill. Most of that is going to be associated with the Lambda function running. So if you ever run this, don't blame me if you get $300 in your AWS bill. I told you so. There's cash there. And that cash doesn't come to my pocket. It goes to AWS. Okay. And I also extracted identity pool IDs from other sources. Those other sources were GitHub. I just did a GitHub search through their API and got results. Shodan, Sumai, Google, Yandex. Just calling the APIs and getting results. Nothing special there. So, internet, done. Now I have many identity pool IDs, and for each identity pool ID, I got the credentials, the AWS credentials. But those credentials are simply strings. They are 3 long, randomly generated strings that don't have any meaning. So I had to perform permission enumeration for those credentials. There are 2 ways to do permission enumeration in AWS. One way is with the credentials that you have, you call the IAM service and query your permissions. That's only possible if the credentials that you have permissions to query the IAM service. In most cases, in this research, that doesn't work. So I had to do something else. I had to perform a brute force process. The brute force process is simple. You call an API in AWS. If you get 403, then you are not allowed. If you get a 200 response with some content, then you're allowed. Brute force. There are a few things in this brute force process. First of all, I didn't want to break anything. I was doing this against AWS accounts for which I never got the permission to hack, and I was completely unaware of who owned each AWS account. So I didn't want to break anything. So I did just get, list, and describe calls. Those are calls in AWS which are read-only. You could potentially, if you want to, use these credentials to run a test for brute forcing purposes to see if destroy the whole AWS account works. If it worked, yeah, it worked. But no, shit, this worked because you destroyed the whole account. So you just want to do, when you're doing permission enumeration, read-only attempts. Also, something else is that in AWS, and by calling the AWS APIs, you can read information about a service or read information stored in that service. Let me give you an example. S3. You can perform an API call, which is going to return the permissions associated with a bucket, or you could run an API call that's going to list the content of the buckets, and another API call which is going to download the whole content of the bucket. Both of those are read-only. I'm only reading. But I didn't want to get access to customer information because that's most likely illegal, and I don't want to go to jail. I'm too pretty for jail. No, not really. Okay, so when I was doing the permission enumeration, the first thing that I tried was a tool called Pacu. Pacu is like Metasploit for the cloud. It's pretty good, but the permission enumeration module that it has was slow, and it wasn't complete. It only supports a couple of AWS services. And I wanted a really in-depth view of the permissions that I got. So I created my own tool, Enumerate IAM. It's open source. You can quickly find it. That uses threads. It uses a connection pool. It uses different tricks, very simple tricks, to improve the whole process of enumerating permissions. And it does this permission enumeration for all services in AWS. This is how it looks. Enumerate IAM, access key, secret key, and it will tell you which API calls worked and which ones did not. Permission enumeration, nothing fancy here. So, before we go into the details of what I found, The research that I did only included the unauthenticated roles. Cognito, as I told you before, has two different access types, unauthenticated and authenticated. In order to test the authenticated role, you need to authenticate using Facebook, Google, or some other process, and then you get the credentials. With the unauthenticated role, which is what I tested, you don't need to authenticate, and you get the AWS credentials. I tested that one because it was easier. No other reason. But the thing here to notice is that most likely the permissions for the unauthenticated role are going to be less or equal than the permissions for the authenticated role. And all these results were for the unauthenticated role. So if you guys ever go through the process of replicating this research with the authenticated role, the results are going to be much worse. And they are bad as it is. All right, so data. Before we continue, any questions? No? All good? Great. Data. I found around 3,000 identity pool IDs. Most of them came from Google Play. And this is something that I expected because Cognito is targeted for mobile application developers. So this is something that I really expected. And I got other IDs from GitHub, and Common Crawl, and some other sources. Some of those identity pool IDs were usable, others were not. Some identity pool IDs did not exist. So there was, for example, an application in Google Play which referenced an identity pool ID, but the identity pool ID was removed at some point from the AWS account. Those does not exist in this line. Invalid configuration, at some point, for example, the developer was testing this and he broke it. He broke the configuration. It's unusable for me and it's unusable for the real users of this Cognito identity pool. And around 300 only allowed authenticated roles. The good thing is that 2,500 did allow unauthenticated access. And when I was doing the scoring to kind of assign a score between 0 being really secure and 10 being really ugly, insecure, and this needs my attention. When trying to score the permissions associated with each identity pool ID and identity pool incognito, I started to ask myself, what is insecure? Because application A might require permissions 1, 2, and 3. And it might be completely secure and required for those permissions to be there. Application B might require only permission 1, but it has 1 and 2. But I don't really know the applications and the use cases behind the user roles that I enumerated permissions for. So I started to think, and a few of the API calls that I found and that I enumerated started to feel like they were insecure. And those were S3 list buckets, DynamoDB list backups, list tables, and Lambda list functions. So I said, if those are allowed, then it's insecure. But why? If we go back to the example, the mobile application that's uploading images to S3 knows the name of the S3 bucket where it will upload the cat pictures. The mobile application, when it's setting the title for those images, it knows the name of the table where it needs to write the content. And I saw no reason for almost any mobile application to have access to list buckets or list tables. And certainly there is no reason for list backups in DynamoDB. DynamoDB is a NoSQL database hosted at AWS. So there's certainly no need for an application such as the one that I explained before to have access to list backups. So with this in mind, I found that around 20% of the Cognito installations allow list backups, around 20% list buckets, and 4% list backups. So this result is telling me that 20% of developers, at least 20% of developers, are misconfiguring AWS Cognito. They are assigning more privileges than needed by the application. And with those permissions, attackers can do really bad things. Sensitive data. During this research, I was able to access, through the credentials that I extracted from Cognito, I gained access to a total of like 13,000 S3 buckets. Those 13,000 buckets, around 900, have sensitive information. How do I know that they were storing sensitive information? Just because of the name of the bucket. I never read the contents of any buckets. Is there a camera there? I never read AWS, I never read. So if the title of the S3 bucket says credit card, password, backup, and some other keywords, then it holds sensitive information. So I was able to identify 900 buckets with sensitive information. An attacker could have read the sensitive information stored in that bucket. The same goes for DynamoDB tables. I was able to list 1,100 tables in DynamoDB, and around 40 had sensitive content. Once again, if the table name was password or secret or something like that, it was sensitive. Something else that I found that was interesting is that when I did a lambda.listFunctions API call, the result included the names for the lambda functions, but also included the user-defined environment variables for those lambda functions. And it seems that it's a pretty common practice to use environment variables to hold secrets. So I found 78 environment variables with API keys, database passwords, and many other things. Yeah. Cool. Questions so far? No? Great. Root cause analysis. Why is this happening? Why are we seeing so many, 20%, that's a lot. Why are we seeing so many AWS Cognito configurations which are insecure? I think that there are two main reasons. First, documentation. The documentation before this research was insecure by default. How does a developer create something in AWS? He goes to the documentation, reads, copy, paste, play, it works, hey, I'm done. That's the average developer day. And no offense to all the developers in the audience. So the official documentation was insecure by default. There were examples which were giving developers really insecure policies to associate with Cognito. Policies that allowed a lot of actions which were unnecessary, and policies which are going to lead to the vulnerabilities that I showed before. I talked with the AWS security team about this, and their solution was to add a warning to a part of that documentation. And this is just an example. They added like 3 or 4 more warnings. The warning basically says, this is an example, don't use it in production. They didn't fix the documentation itself because they thought it was going to make things more complicated for developers. But they did add a warning sign. There are some restrictions on the permissions that developers can associate with an unauthenticated role. So when the role is unauthenticated, you can only assign permissions for 26 services. It's impossible to associate permissions for EC2 or for IAM, but it is possible to associate permissions for DynamoDB, S3, Lambda, and many other services. And as I told you in the introduction, I was able to use misconfigurations in the permissions for an unauthenticated role to modify a Lambda function and elevate my privileges into the AWS account. So even with these restrictions, it's really easy for the developer to make a mistake and expose the security of the whole AWS account. For the authenticated roles, there are no restrictions. You can simply assign any action for that role. It will work, no restriction. Also, this is bad because most applications, like the example that I gave, want you to register. Most applications want you to authenticate, to create a user, to authenticate, and to interact with the application. So being authenticated doesn't mean much in this context. It just means that you clicked on create my user, or you clicked on authenticate with Facebook. That's all that it takes to be authenticated in a Cognito application. So the developers can shoot themselves, and AWS isn't doing much about it. In my opinion, they should add to the UI a big warning when you are doing something wrong. So if you're a developer and you're assigning excessive permissions, and it's pretty easy to identify when that's happening, the UI should warn you. The UI should show a big warning in red saying you are trying to do this, this, and this. This is insecure because this, and this. Hire Andres Riancho if you don't understand why. That's a warning that should be there, hopefully. But no kidding, there should be a warning. So, for the developers in the audience, please follow the least privilege principle. If you're ever configuring anything in AWS, and specifically AWS Cognito, follow the least privilege principle. Only assign the permissions that you require and your application requires to the roles that you associate with Cognito. If you assign more permissions than the ones that are required, someone eventually is going to hack you. I never mentioned anything about object-level permissions. Once again, if we go back to our sample application, there are images and there are titles for those images. The only user that should be allowed to change the title for one of those images is the user that uploaded the image. I never even attempted to test for the security of object-level permissions, because in an automated way, it's impossible. But you, as a developer, need to understand this and need to properly implement it. All right, bonus, before we finish. Since I was grabbing the internet, I also tried to find hard-coded AWS credentials. I didn't just try to find identity pool IDs, I also tried to find this. And I found 26 root accounts in AWS. A root account is the master account for the master user for the whole account. So if you have that, you can do whatever you want. And I found 26 of those online, ready for somebody to do some evil. I found 38 high-privileged accounts, also hard-coded in some HTML file somewhere on the internet. And most of these root accounts came from the command crawl. So if you ever want to get a root account, instead of going through the whole process of creating your account, use CC Lambda, do a grep, and you find most likely root accounts there. I notified the AWS security team about all this, not only about the hard-coded credentials, but also when I was starting with this research. And before I did anything, I sent them an email and told them I'm going to be doing this, this, and this, and then I'm going to be doing this and this. I explained the whole process to them before starting, because the whole process is really noisy. From my IP address, I was going to be performing brute force of thousands of accounts. That was going to be noisy and detected in many ways. They told me, please consider don't doing it. And I said, I'm going to consider it, thanks. And I'm here, so. Okay, closing thoughts. This research can continue. You can continue this research. I'm done with it, but maybe it's interesting for somebody else. You can extend this research by looking into iOS applications. You can extend the research by trying to do the same with other cloud service providers. Maybe Azure has its own Cognito. Also, you could try the authenticated role analysis, doing the same but with the authenticated role. And you could potentially do some privilege escalation analysis. Try to answer the question, how many accounts can I own through Cognito misconfigurations? That's a potential question that you can answer. It says danger there because privilege escalation techniques often require you to modify the AWS account in one way or another. And usually you don't want to do that if you don't have permission. Great. So, key takeaways. There are 3 things that you should take away from this talk. AWS Cognito is commonly misconfigured. So, and it's really easy to exploit. So if you're ever doing an assessment and Cognito appears there, you should be happy. You have access, most likely. 20% of chances of getting something good out of that. It's possible to grab the internet and find vulnerabilities, whatever you want, using CC Lambda. If you ever dreamed about doing a grep of the internet, CC Lambda. And it's also possible to enumerate the permissions associated with AWS credentials using enumerate IAM. And it's going to be fast, and it's going to be safe to run in any account. All right? Questions? No. Great. Excellent. All right. Thank you very much.